This problem is asking to pick a choice that shows an example of a 6th-degree polynomial with a leading coefficient of 7 and a constant term of 4. So this is really asking me for a few things. A 6th-degree polynomial with a leading coefficient of 7 and a constant term of 4. So it's really asking me for a few things. So in problem, let's put all of our options first in standard form. So in standard form, that means we're going to order them with the highest degree first and then down to the lowest degree with the constant last. So in option 1, I'm just going to rewrite it. So we have 6x to the 7th minus x to the 5th plus 2x plus 4. So we'll see here this happens to already be in standard form. This happens to already be in standard form because x to the 7th is the highest degree. So x to the 7th is the highest degree term. And then we have to the 5th, then to the 1st, and then our constant. So in option number 1, this is not a 6th degree polynomial. This is a 7th degree polynomial. So this is a 7th degree polynomial because, if we'll see here, this is a 7th degree polynomial, but we're really looking for a 6th degree polynomial. It also has a leading coefficient of 6. So a leading coefficient of 6, and we see that here. So I'm trying to highlight it similar to what we have in the problem. But it does have a constant term of 4. So we'll see here that based on what the problem is asking us for, the only thing it satisfies is this third option, the constant term of 4. In option number 1, they're hoping that we confuse what they mean by degree of polynomial and the leading coefficient. So we're not going to pick option 1. Okay, let's look at option 2. Actually, I'm going to write option 2 down here. Let's look at option 2. So we have 4 plus x plus 7x to the 6th minus 3x squared. So we want to rewrite this with the highest leading degree first. So the term with the highest degree for an exponent is x to the 6th. So we're going to put 7x to the 6th, and I like to cancel it out, that way we know we had it. The next highest degree term is going to be negative 3x squared. So minus 3x squared plus x that we have here plus 4, our constant. So we'll see that this is a 6th degree polynomial because our highest exponent is 6. So this is a 6th degree polynomial. And we'll see that the leading coefficient, so the number in front of the term that has the highest exponent degree, is 7. So we have a leading coefficient of 7. I'm going to highlight that in red. And then we have here, our constant term is 4. So let's go back to what the problem is asking. We have a 6th degree polynomial, a leading coefficient of 7, and a constant term of 4. So number 2 is going to be the correct option. We don't need to check 3 and 4. I'm going to not write it all out, but I can talk about it. Actually, that's it. So we have a leading, that's it. So number 3, I'm just going to highlight them. We have a 4th degree polynomial with a leading coefficient of 7, and a constant of 6. Again, we would have to write this in standard form. In standard form, it would be 7x to the 4th plus x squared plus 6. So let me highlight it there as well. And then in option number 4, we have 4x to the 6th plus 5x plus 7. But here, we do have a 6th-degree polynomial, but the leading coefficient is 4, and the constant is 7. So you'll see here in all the options, they give us 4, 6, and 7 as the degree polynomial, the leading coefficient, and the constant term. So it's important to remember which represents what.